SOS teams face massive logs daily. Traditional threat hunting is manual, reactive, and reliant on a few experts, leaving critical security gaps. This is where our solution comes in. External SOC logs flow into S3, where AI agents continuously hunt threats and surface high-confidence findings in QuickSight. Now, let's jump into a live demo. When logs are uploaded into S3 buckets, AWS Lambda trigger our SageMaker endpoint, where our pre-trained model predicts potential threats. Then, based on respective organization threat playbook, another Lambda function applies, another inference layer based on their business priorities, like prioritizing certain threats found. This final output will then be stored in S3 bucket. Predictions are visualized in Amazon QuickSight dashboards for real-time monitoring. High-confidence threats trigger automated alerts via Amazon SNS, keeping your security team informed without delay.
We'll talk about our system in more detail. First, when SOC logs are generated, they are uploaded into our dedicated S3 bucket. This event immediately triggers our first Lambda function. Lambda is responsible for invoking the SageMaker endpoint by passing in the bucket name and the file name. This way, SageMaker can directly pull the log files from S3 and start analyzing it automatically, without any manual intervention. We can see in our logs that the SageMaker endpoint execution begins as soon as a new log file lands in the bucket. Once the SageMaker analysis is complete, the Lambda function takes the output and stores it into another S3 bucket. That output isn't used in isolation. It is combined with our organization's threat model file, which is maintained in another separate bucket. At this point, our second Lambda function, what we call the second inference layer, is triggered. This second layer is a critical part of the architecture. It doesn't just passively accept the AI model's results. Instead, it merges the raw detection results with business-specific intelligence. Things like which assets are most critical, the scope of the potential attack, and a set of recommended response actions. This gives us not just a prediction but also a clear priority score and action plan. Finally, the curated results are stored into a well-structured S3 location. From there, downstream services such as QuickSight can pick them up for visualization, and our AWS SNS services can act on them for rapid SOC notifications. Now, let me shift to our AI model itself. We trained the model using XGBoost algorithm, which is well known for handling tabular data and producing high accuracy in security detection tasks. The training was conducted inside SageMaker Studio using a Jupyter notebook. We first created a training job model, which is the prerequisite step before deployment. Once the training was successfully completed, we registered the model and then deployed it as a SageMaker endpoint. This deployment is what makes the model live, allowing us to invoke it on demand from anywhere within our project environment, fully integrated with the Lambda workflow.
Okay, now I will continue with the configuration walkthrough with Amazon Glue for Crawler. The purpose we did Crawler is because we want to use QuickSight as the dashboard. So as you can see, I created a crawler, and this crawler actually points to the S3 bucket which stores our endpoint output. Then I ran my crawler, and under tables, a table was created, and this is the proof. It's located at our S3 endpoint. Now I will move on to the dashboard. So you can see this is our dashboard, and then this information threat found, and these three types of threat found, which is critical, medium, and low, is updated in real time based on the info in the S3 bucket. Then we have threat details, and we also filtered that the critical threat will be in red, medium orange, and low in yellow. Moving on, we also have this threat analysis by last 30 days and also this map alert based on IP. Okay, now as you can see, these two bar chart left and right, we actually got it from our organization threat model. On the left, this bar chart shows department priorities, which you can see the IT is the highest priority, followed by HR and so on. Then, for this bar chart is about assets, the web assets is the most important one, followed by server. So what does this mean that actually, for this, to use this as an example, if both IT and HR show critical threats, the SOT team must immediately focus on the threats on the IT department first, as is the top priority, and then they will only move on to the lower threats.
This is our AWS architecture. Our flow starts when SOC logs is uploaded into S3, where Lambda will act as a trigger to trigger the SageMaker endpoint. We chose to store our logs in S3 bucket as it is the most cost-effective for raw data. Besides, we chose Lambda as a trigger as it is serverless and wouldn't add operation overhead. After the SageMaker do its analysis and has its output, the output will be sent to AWS Lambda for a layer 2 inferencing, where this will be based on the organization threat model stored in this S3 bucket. Then, it will be displayed in AWS QuickSight, which is a dashboard function. We decided to use QuickSight as it has a native AWS connectors, as well as AWS Glue, which is also serverless to infer the schema from S3. Our SageMaker pipeline is fully deployed in SageMaker Studio. This is because there is an end-to-end machine learning workspace here, as well as a managed compute environment.